Everyone, and let me also start. Okay, we are good. Thanks, everyone. Let me just welcome all the people who have recently joined. Thank you so much. And I'm going to explain about the format of how the hackathons happen. People who are joining us on the afternoon sessions, we are kind of making it the blockchain because right now we're in the 7th module. We're going to finish it soon. The sessions will happen towards the evening. Fridays, the blockchain sessions will be happening on Fridays, 8 p.m. and AI will happen at 8 p.m. Thursdays, right? So information for our gold members. If at all you are planning to attend both, AI and blockchain will happen on Thursday and Friday, 8 p.m. Right? Okay. And for the people who have recently joined, let me point you in the direction of how the hackathons happen. Right? So I'm just going to share my screen. Let me know if my screen is visible. Right? Okay. If my screen is visible, type V in the chat box. Great. Okay, so now this is how your course is structured. And you can see all of the modules. Thank you, Sujana. All of the modules are listed out here, starting from orientation, then module 2, 3, and we proceed towards 10 of our modules, right? So what happens in hackathons is, hackathons are a way to revise the concept covered by the primary faculty. Here, by Professor Pandurangan sir, Satya Peri sir, or other faculty, right? So in today's hackathon, we are going to cover the module 8. We are going to revise module 8. One good thing about today's session is even people who have recently joined, because this will not be having number crunching or technical concepts. We are going to keep this the session shorter, the beginning of the consensus. We're also going to continue about regarding the consensus in our upcoming sessions as well, right? So it will be roughly a 45-minute session. And people who have recently joined, you can always start from the beginning, right? From module 0, 1, 2. And if at all you find any query, you can always bring your queries to the hackathons, right? So these hackathons happen in a cyclic fashion. From module 1 to 10, we'll finish first, and then we'll start from beginning again, right? So it's nothing as if you're missed, and you don't have to rush yourself to finish your, try to catch up with the hackathon, right? So you can go with your own pace, and if at all you have just started, not a worry. Yeah. So how to start? Once you log into your Teachable account, go open any of your lecture, and you will have an unlisted private video only accessible to you, which you can start watching from there, right? So the same lecture will be revised in the sessions here, right? So if that is clear, type C in the chat box, especially the new members. That is clear, type C in the chat box. Great. Thanks, Michelle. So people who are joining us on our social channels can type in the comment section. Thanks, Vijay. Thanks, Lakshman. Okay, great. Now, today we are going to cover blockchain, the 8th module, begin the 8th module. The people who have just recently joined also can go through, but I would still suggest you to start from the beginning. But this will be a lighter session, and you'll have an understanding of consensus. What is consensus? Because in our previous sessions also we have covered most of the knowledge of consensus previously, but now this will be more focused only on consensus, right? Okay, let's begin. So I'm going to share my screen, right? Okay, so if my slides are visible, type V in the chat box if it is visible. Great. If my audio is also clear, yeah, thank you so much. Thank you, Chandan sir. Okay, so now we'll try to understand what is consensus. Thank you so much, ma'am. Right. So basically, consensus, first thing is blockchain, the whole network is an decentralized system. It's a peer-to-peer system, peer-to-peer system. And there has to be some ground rule set, and we need to understand who says that this is agreed, right? So we should know when something has to be agreed. So there has to be some mechanism, some algorithm or a protocol, right? So consensus in general, the dictionary definition is agreement. So a consensus is a common agreement that all the people in a group come to, right? So when we are talking about our blockchain peer group or network, consensus means a common agreement across all the nodes, right? All the individual people who are participating in the blockchain, right? So the process by which all peers in a blockchain network establish a common acceptance or consensus on the distributed ledger real-time status, right? So real-time state, meaning what is distributed ledger for the people who have recently joined? Because all of the transactions happen, they are fully transparent and are available for everyone. So that is why the ledger, the list of all transaction is called the distributed ledger. So it is distributed among all the nodes, all the participants, right? So that is about consensus. We have previously discussed a little about how agreement comes, like everybody agrees on something. Today we'll go a little deeper onto that. So consensus algorithms are critical components of blockchain networks because they ensure the integrity and the security of this distributed computing platforms, right? So we'll understand how they ensure the integrity and the security, right? So because as much as we want everything to be agreed and on a common agreement, we also want the system to be secure, and how consensus protocols or algorithms are helping us to achieve that, we'll see today, right? So now why the consensus is required? So because we have understood that blockchain is decentralized. Now, with that property, it being decentralized, what benefits we gain? We don't have to trust any one person to keep the state of the truth to the system. I mean, you don't have to depend on one person nobody gives the permission for someone to join or restrict their access to participate in the system, right? Because it is decentralized, right? It is not dependent on any one person, right? So that is why we require the consensus, and the consensus algorithm is a strategy or a way that all the group of computers use to agree between each other on what's true. Here, the truth is basically, for example, whenever a new block gets created, we want everybody to agree that this is a block, there has been enough work done, and this is a genuine block based upon the protocol, meaning it is a verified block. So there has to be a protocol. We'll see that a little in detail here. In our previous sessions in module 7, what we have understood is we have understood what every block has. Every block has a block header, and in each header, there is something called the block hash, right? And this hash, how is that generated? Is when there is a unique random number that a miner is a person who tries to validate all the transactions that are happening on a network. He validates a few transactions and uploads into a block, right? So that is what a miner does, right? Let's see that visually and try to understand, right? So, and there are multiple types of algorithms, like there is no one way to agree, right? So even in common cases, you can say that if everybody agrees, like it's a democratic way of like everybody agrees, like or most of the people agree, then it is agreed, right? So how to come to a common agreement could be different ways. Like it could be like in a regular system, more people votes, or the authority of a judging panel. So there could be many ways to come to a common agreement. But similarly, in blockchain also, we have different ways or different algorithms. A few popular ones are proof of work or the proof of stake that we'll discuss a little, right? So there are different flavors of consensus algorithms that people have applied, that each have different every algorithm has different properties, right? Like A democratic way of coming to an agreement has a different property than a one single body taking decision. Similarly, each algorithm has different properties or trade-offs in terms of how secure the agreement is and who gets to vote on what, right? So that is a different type of algorithms, right? How to come to a common agreement? There could be many ways. But in general, the purpose of consensus algorithm is just to manage which participants in the network get to set the state of the truth, meaning what is agreed and what is not, right? So that is what we are going to see. Two types of two flavors or two types of consensus algorithms that are most popular or prominently used are the proof of work and the proof of stake, right? So proof of work is a concept that was developed initially for the first time in 1993, right? So it was used for a different application, right? To come to an agreement, right? To fight spam, right? At that moment, 1993, fighting spam was a problem, and consensus, like the proof of work means any person, if he has done enough amount of work or computation, then that is the person who gets to say what has to be done, what is true and what is not true. So that was long back 1993. Something similar has been used in 2009 when the genesis of blockchain was happening, right? So at that moment, what happened is it was used and tweaked for blockchain's needs, and we'll see how that works. And that is where the proof of work is one algorithm. It is not something that was customly developed for blockchain alone. Similarly, this proof of work became so popular that many other networks, like blockchain networks like Ethereum and every other like different blockchain networks use different consensus algorithms, but most of the prominent one is the proof of work, right? So if that is clear, like what is consensus is clear, type C in the chat box. Okay. Thanks, Prashant. Thanks, Vijay. Okay. Now, yeah, thanks, Ravinder sir. Thanks, Vijay. Thanks, Sharayo. Now, let's go by the definition. The very first algorithm was proof of work, which requires computers to use a lot of processing power, and the amount of processing power they use constitutes the amount of voting power they have in the network. So that is how earlier this was devised. And then the other way also was proposed, another consensus, another way to come to a consensus was proof of stake, which means the amount of funds that a person or a node has on them, or stake, the amount of, maybe if it is Bitcoin we're talking about, it's not for blockchain, but some customized use cases of blockchain might be using proof of stake, where they use the amount of fund that they have. Those people only have the way to set that what is true and what is to be agreed on, right? But there a little of what you call centralization comes in picture. So for that reason, proof of work is something which can happen peer to peer, right? So it is dependent on context. Proof of work may work well in one context, and proof of stake might work in other context, right? So we'll see both of them in a deeper way, right? So what is proof of work? The mechanism is popularly used in the Bitcoin algorithm. This is to verify a transaction. Participants need to publicly prove the work done. In our previous sessions, in our module 7, we have seen each miner, what they have to do. They have to find a variable, and the probability of finding that variable is very small, and that is called nonce. This nonce, if they find, and then they include it with the hashing, right? They hash all the transactions. A miner, what he does, he validates all the transactions, and when he does the hash along with this new randomly random number that he got, which is called nonce, what happens is, if he verifies, with the equation. If the whole hash is less than a set threshold, which we have discussed previously, people who are just joining today in this session, do not worry. Once you go back, it will become clearer, right? So whenever a miner, he has to solve a problem. That when he solves that problem, that becomes the proof of work. That, like for example, if there is a teacher-student case, a person goes back home, does a lot of homework, makes a lot of mistakes, erases, and all those things, and then arrives to an answer. Then we know that the work has been done. Right? Similarly, to verify a transaction, also a miner has to do a lot of work, a lot of computation, and that is called the proof of work here, right? And what work the miner has to do in the blockchain's case is he has to come up with a random number or nonce that will help him make the hash of the whole of the transactions in the block less than a set threshold. If it is first time you are listening, we have covered it in the seventh module. Do not worry about that. Okay. The more work is done, the faster a new block is generated and the faster miner gets their reward. This is also true. And there is also a way that every miner has to do an amount of work, which, to generate a block, it takes 10 minutes for a person to generate a block, right? So he has to has to roughly work for 10 minutes, right? So that is all covered in our previous modules. But to understand the concept of proof of work, it is basically work done by the miner. And if he has, in a way, solved the puzzle, the puzzle is basically, we have seen what is the puzzle called. The puzzle is the cryptographic puzzle, which means finding a nonce, hash of it less than a set threshold. If he is able to achieve that, then he is able to prove his work. So that is what proof of work is, in a simple way, right? So if you have understood briefly also what is proof of work, type U in the chat box. Thank you, Sujana. Thank you, Prashant. Thanks, Vijay. Thanks, Rindra sir. Okay, great. So it's basically a miner telling that I have successfully solved the problem and hence, I am able to prove my work. So that is what is happening. Great. So let's see this. For example, there we have 3 miners in our case, right? Out of these 3 miners, this is the person who's able to solve the guy in middle is able to solve the puzzle. Okay. And then what happens? Everybody started competing for trying to solve puzzle. What is the puzzle? Everybody is trying to validate a few transactions and find that nonce or the random number at which his whole of the hash of the transaction is less than a set threshold. If the middle guy is able to do that, then only he is able to upload a block to the network, right? So we have understood this. So how many of you understood that only when he is able to find the nonce and able to solve the challenge, then he is able to publish the block? If you have understood this, type U in the chat box. Great. Thank you, Sujana. Thanks, Prashant. Now, when this person finds the nonce and his hash is less than a set threshold, meaning he solves the challenge, he's able to upload. And when he uploads, the other people validate, right? So the hashing, the actual work of solving the puzzle takes a lot of computation, but verification does not take much work, right? So basically, if you have to verify somebody got an answer, you have to see maybe a few steps towards the end if he is able to get the answer or not, right? So you don't have to see the whole of the work, rough work, fair work, what he has done sometimes, right? So verification, it becomes easier. And how do the other people verify? Because this person has generated the nonce, and that when he uploads a block, the nonce value also gets uploaded in the block header. And the other people can verify based upon all the transactions that were uploaded along with the nonce. And then if it is getting validated, if the whole of the hash is less than a set threshold, meaning this person has done it correctly and he has done it through the right ways, then everybody starts verifying the transaction, right? So this is how this works. The first step is done. He find a nonce, he uploaded the block onto the network. And then what happened? The other people were starting to verify this, right? So within 12 seconds, the update that a new block got uploaded reaches up to 85% of the network. So many people start verifying, right? So more verifications happen, the stronger his case, like his block is going to remain, right? So verification is a different thing. Confirmation is a different thing. Confirmation means if there's a new block that comes, and when that new block is coming, every new block means that that block only got added because this block was genuine and the generated in a right way. That is one confirmation. Every new block will become a confirmation, but verification can happen by anyone in the network. Uploading of the block will be done only by the miners, but it can be verified by anyone, right? So that is what we are trying to understand here, right? So now what has happened in the background is this person found a nonce and he was able to include it with the data of all the transactions that he had put in the block. And when he did that, and he used the hash function. We have talked about the hash function in our previous initial third, fourth modules only. So once you go back, go through that, you will understand it. Right now, if people who have joined recently, you can just understand overview of it, right? You don't have to, know what hash function is immediately. If you understand briefly also, it is fine, right? So, but you have to start from the beginning to have a clear picture. So now a nonce is generated, a random number. Nonce is here a random number, which helps him, whenever he generates a hash, that hash should match a set condition. That is, it should be less than a set threshold that gets updated every 2000 blocks, right? We also spoke about that in our previous session. So once a person is mining, meaning that he has done all this work. And whenever after finding the nonce and doing the hash function, if he is able to generate the block hash, that is what means that this person has done some work. That is what is the proof of work, right? If he is able to generate the block hash, his proof of work is there, right? So let's go forward and see. Now he has generated a block hash and then he published the block to the network. And whenever a new block, so the blockchain, whenever there was a new block that got uploaded, corresponding to that, there is a block hash. The block hash tells that each person who uploaded that particular block or published that block has done some amount of set work. So that is the proof of work, right? So if proof of work is clear now, like in a better way, type C in the chat box. Great. Thank you so much, man. Thank you, Randhar. Right. So now, which means when this person created the block 6, right, uploaded, published that block 6, he confirmed the previous blocks also. And we also know that because there is hash and everybody started verifying and agreeing, then meaning that the enough work was done by that person. And we can kind of agree that this is a valid block because he found the hash, he found the nonce, which requires a lot of work. If then only he'll be able to generate the block hash, right? So if there is block hash, meaning he found the nonce, which requires a lot of effort, meaning that he has put his effort and then only the result has come. Right? That is proof of work in simple. Right. So now we've understood proof of work. We'll go forward. And this is how everybody's proving that they have worked, and how others are coming to common agreement that because it is set in the beginning only that if somebody has done enough work and he's able to generate the block hash in the right way, then he has done the work, and then everyone can come to a common agreement that this block is to stay. This is a valid block. And when that happens, the person gets some reward. The miner gets a block reward first for uploading the block, publishing the block, and he also gets some transaction fee as a reward. That the amount of transactions that were there in that particular block, there is some transaction fee comes as a reward to that person. So he's having two kinds of rewards in this, right? So because he has done that work, he is getting rewarded, right? So we'll also see that in clear right now. Right. So now we will see more about the consensus protocol. We have understood the proof of work part of it, which helps us keep the integrity portion. But how does it also help in the security portion is something that we are trying to understand now. Okay. Now, let's say there are multiple nodes on the block A, B, C, D, E, F, right? A, B, C, E, F in this picture. Okay. Now, what is happening is everybody has a copy of blockchain, right? Their own block, right? So till all the fourth blocks, everybody had a valid generated block, right? Now let's say A is a person, he's trying to corrupt any of the nodes in between, right? So if he is trying to make any change in this particular node, after that node, many other new blocks got created. But if somebody is trying to make a change, then what happens? Everybody in the network says, hey, there is something going wrong at your copy of the block, because there's a common ledger, right? Everybody has a common ledger. And now they say, this is not how the actual blockchain is right now. The state of the blockchain is not that. So you might want to check it. Right? So somebody wants to corrupt in between, it is very easy to catch because everybody else will say that is not how it is going to work. Because if somebody tries to make some change here, the other next coming blocks also get edited or modified. And that is the reason everybody will be like, your copy is wrong, just follow us, right? This is the right copy. And that can be caught. Now, this is the case when somebody is trying to make do some mischief in a block that is already published, right? So we'll also see what happens if he's trying to upload a block with some error in it, right? So we'll also do that. So, but if everyone understood that if somebody is trying to make a change in any of in between blocks, it is easy to catch, and others will be able to catch that, because it is not agreeing to the common ledger. If you understood that, type U in the chat box. Thank you, Sujit. Thanks, Prashant. Thanks, Lakshmi. Thanks, Ravindra sir. Great. Now we've understood this. Now let's see if the person is trying to make, if he's only uploading a block, and if when he's uploading the block, he is trying to do, add a, hyped transaction or trying to do some mischief in the upcoming block. So what is going to happen? Let's say now he's going to add a new block. Everybody is in this way. Here he wants to add. First of all, normally, if to upload or publish a block itself, it takes a lot of computation, right? So consensus, by making it difficult, discourages miners to actually do some malfunction or to try to do some mischief when he's trying to upload, or try to do some fraud or anything when he's upload, because already it is going to be a lot of computation. There's a lot of power that he has to put in, a lot of time that goes into that. And in that also, if he makes an error, that he will never get the block reward or the transaction fee reward, meaning he's lost twice. He has lost the the effort that he has put in, the computational effort, and also the reward that he was to get. So that is going to be the problem that he'll get into. First of all, by making it hard, consensus is the protocol is making, having a, giving a message to everyone that if I try to upload something also, I will get rejected. I should not. But let's say this person goes ahead and does it, right? He takes the effort to do some error in the new block that he's creating. Now what happens? As I've told, first, if at all a person has to upload a proper, true, genuine block, he'll get the block reward and he gets the transaction fee reward. Let's see if he's trying to make an error there. He's losing the reward and the block reward and the transaction fee reward. First thing, right? And all the computational energy or whatever thing he has put also is being lost. Now, what happened here is whenever something is some error a person is trying to do, other people try to verify it. When they go ahead and see that this person's the way of generating the transaction was not in the actual protocol defined way, meaning his nonce is not helping him have solve the puzzle or have the hash which is less than the set threshold. If he's not agreeing to the protocol and still trying to upload some error, he's losing again, right? So he's not able to do that. He also lost the block reward. So now every other node will say, hey, it seems like you uploaded, but I'm not able to tally your thing. So I'm not going to mark or verify this, right? So it's like that. So somebody is trying to see everybody's, whenever a new transaction record or a block is getting uploaded, everybody is trying to see if it is genuine or not. And if they see that it is genuine in tallying with the protocol rule set, then it is going to stay, right? So it was first of all easy to to identify if somebody is trying to make a change in a already uploaded published block. But if he's trying to make an error in the new block also, other people have to verify. Without verification, no one can take his block as a valid block, right? So in our previous module, we have seen a block becomes a permanent block if it has at least 6 more blocks in front of it, right? Meaning if any block that got added out of the 6 blocks after this says that I see there is some error in this, that block is going to get rejected. So as soon as a miner uploads, he cannot be fully happy that his block is going to be valid. 99% is going to be valid if he has done it in the right way. But the protocol requires at least 6 more blocks in front, meaning there is a strong proof that it is a valid transactions and the other miners also have verified and then expanded on the blockchain. If they would have found some error, they would have rejected that copy of the block, right? So this is how the protocol discourages anyone trying to make a fraud or a transaction edit in the new transaction that he's uploading, right? One is loss of reward, and the second is without the enough confirmations and all, it is automatically going to be rejected, right? So if you understood how a new block also cannot be having some error in it, if you understood that, type U in the chat box. Thank you, Suju. Thank you, Rahul. Great. So that is the reason every miner, if his intention is not to make some transaction error or fraud, he double, triple checks, because if he's not able to get a confirmation, it's going to be loss of his time, effort, and also the reward. So before uploading only, a person is double, triple sure, and somebody is trying to make some error also willingly for some reason, he'll not be able to go forward, right? Thank you, Shirai. Right. So this is what is the consensus protocol. Now that is where the common ledger actually becomes really distributed, and actually there is peer-to-peer confirmation happening, right? So this is the logic behind everybody agreeing that this block is going to stay, right? Because every block stays forever in that particular position, and everybody is now agreed only when a person is going through the protocol and generating a nonce and a block hash, and he's telling that I have done enough work to generate this. That is the reason I got the block hash, right? So that is what is proof of work for you and the consensus, right? So if you've understood everything till now, type U in the chat box, the overall. Great. I think, yeah. Great. Okay. So now we're going to conclude, this. Let's say now A understood that he cannot do any error. So what happens? He goes forward and does the right way of uploading. But will everybody accept the copy immediately? They'll not accept the copy immediately. They are going to do some validation, the confirmation, right? So the confirmation requires a few steps, which will be taken by their either their wallet or their the Bitcoin wallet, or their blockchain software that they have installed on their device, right? So what it does, now A has uploaded. I'm not going to confirm it. What I'm going to do, first let me check if it is done in a proper way. And when it is done in a proper way, then everybody says, okay, I'm going to confirm this, right? So this is what we have learned till now. Okay, so we'll learn more about proof of stake. Proof of stake is not heavily used, especially not used in many of the primary Bitcoin systems, so the blockchain networks, right? So what is proof of stake? It is also a way to come to a common agreement. So now we have understood the proof of work is a way to come to a common agreement that somebody has put enough work, and then because he has been able to solve some challenge and was able to successfully get a result, then we are coming to common agreement that this block is going to stay. So this is till now. And there are a few blockchain networks where a different type of, there are multiple ways to come to consensus. Apart from proof of work and proof of stake, there are multiple others also, which are not very popular, and you don't have to try to understand them. These two are most popular ones. So now what happens in proof of stake is a voting among the shareholders of a company happens, or among the group, whoever has the high funds or shares gets to say, okay, this block stays, or this is a valid thing. This is valid and this is not valid, right? So that is what is proof of stake. It's a simple concept. There is no math or anything that we are going to discuss, the logic or the problem or something. We're not going to discuss. This is a concept that you just want to understand, right? So basically it's a voting system. The ones with the majority of the shares have the highest voting power, right? So in the proof of stake system, an attack is possible if more than half of the stakeholders join force. Now, because it is happening through stake, if let's just say more than 50%, meaning 51% minimum people say, they say this is valid, even if it's not valid, then the attack can happen, right? So that is what happens. In proof of stake, there is still some error. There's still a way to hack the system if more than half of the stakeholders become together and say, okay, now we are going to trick the system or do something that is not intended, right? So the overall common gain, right? So that is what is proof of stake. But most prominently, proof of work is the system that goes in Bitcoin and most of the blockchain networks. Great. Yeah, so who has raised the hand? Or is it me? Or is it me? Okay, good. Great. Now this is what is proof of stake. Yeah, so a blockchain consensus algorithm is an essential part of any network It defines the entire governance process and ensures that participants follow the rules while keeping the integrity of the data blocks. This is what we have seen. And it's crucial to choose the best consensus mechanism based upon the needs of the business network. So if it's a customized blockchain network for a company, let's say, it's a larger company, then they might be okay with using proof of stake. But it depends upon the context and the need for the business, the needs of the business, right? So that brings us to the conclusion of today's consensus related concepts. And if at all you have any queries, you can put forward. And if everything is clear, you can type C in the chat box. Okay. Great. Thank you, Sharayu. Okay. Thank you, Ashish. And people who have recently joined, if at all you want to go through the recording of the same also, in the same mail, you can see that there will be an image where there will be a play icon. When you click, it will take you to the YouTube of the same stream, right? So many people choose to watch it that way. If at all you have any queries, put it in the comment section or reply to the same email. It will help us, solve your problem or concept, bring more clarity to that. So the people who have recently joined, don't worry. You can start from the beginning. Even if you are in module 2, 1, 0 or anywhere, you continue going forward. And if there is any challenge, you can join the hackathon that happens on Friday, 8 p.m. Join us and bring your query up. Right. So if any other person has any query in previous previous modules, you can go ahead and ask us. Else you can reply to the same email. Right. So I hope that is clear for everyone. Great. So thank you so much everyone for joining in. Right. So people who have everything clear, you can safely drop the call. If anybody has any specific query, you can stay and get them resolved. Anything to the access or anything related apart from that also, you can go ahead and ask us. Right. Great. Okay, thank you so much, everyone. Looking forward for our next session. If at all you understood this consensus portion, you can go and continue watching the rest of the module 8 to have more understanding of the same, and you can take notes of that and take the quiz of it. Thank you so much, Sujiman. Thank you. Thanks, everyone.